Assalamu alaikum. Hello everyone and welcome to my YouTube channel. My name is Nur Muhammad Shabir and I'm a former student in Mehman Academy High. I did my KCSE this year, April 2021, and I scored an A minus of 76 points. Now I have created this YouTube channel today so I can teach high school students tuition classes, topics which have not been understood, questions and areas of set books. Now, I would like you to please kindly drop in the comment box to help me know what to cover and what to start with, so that topics which have not been understood in class can be understood and I can use my resources to teach you students. Now, without further ado, let's dive straight into first lesson, which is atomic structure and the periodic table. Now, this is chemistry, the first topic in Form 2, and it forms the basics of chemistry. The periodic table is an area that is must compulsorily tested in paper 2 KCSE. It was in our time and it will be in yours. So we will start there. So atomic structure and the periodic table. Now, what is an atom? An atom is the smallest particle in an element that can take part in. An atom is the smallest particle in an element that can take part in chemical change. Now, what is chemical change? Chemical change is where one substance, a pure substance, combines with another pure substance to form a new element or a new substance. Let's say water and petrol combine to form a new substance. That way, there are elements in chemistry. Now, what is an element? An element is a pure substance that cannot be split into simpler substances by chemical means. Examples of the elements are sodium, magnesium, and we will go into that, but for now we have to look at the structure of the atom. Now, an atom, we have already described what an atom is. What an atom consists of, this is an atom. An atom consists of a nucleus and energy levels. A nucleus contains subatomic particles which are protons, neutrons, and energy levels are areas around the nucleus where electrons are found. Now, what are protons, neutrons, and electrons? As I mentioned, they are the subatomic particles of the atom. Now, protons are found within the nucleus. So as you can see, this is the nucleus and P represents protons. Protons are positively charged and they have a mass of 1 atomic mass per unit. We go to neutrons. Neutrons are neutral, they have no charge and they have a mass of 1 atomic mass per unit. Electrons are found on the energy levels. Electrons are found on the energy levels and they have a negative charge. Their mass is very light compared to protons and neutrons, which is mass of 1 over 1840 atomic mass per unit. An energy level is an area around the nucleus. An energy level, these are energy levels, these two are energy levels, this is the nucleus. So an energy level is an area around the nucleus where electrons are found. So the charge of an atom, as we will go deeper, you will understand the charge of an atom is due to the protons and the electrons. Protons are positively charged, whereas electrons are negatively charged. Protons and neutrons are called nucleons because they are found in the nucleus of the atom, and each having 1 atomic mass unit, a mass of 1 atomic mass unit. That is what determines the mass, the atomic mass of an element. Now the next subtopic is the first 20 elements. Now, as we explained, what is an element? An element is a pure substance that cannot be split into simpler substances by any chemical means, which means it cannot change by chemical means. So in chemistry we have the first 20 elements in high school, which we will deal with until the end of the syllabus. The first 20 elements are as follows. 1, we have hydrogen, which is represented by H. Now these elements have their chemical symbols as representation. In chemical equations or in chemical formula, you will not be using the whole element as hydrogen. No, you will be using the formulas or the chemical symbols which are as follows. Now hydrogen is represented as H. We have helium represented as He, lithium as Li, beryllium is Be, boron is B, carbon is C, nitrogen is N, oxygen as O, fluorine as F, neon as Ne. Now these elements are in order of atomic mass. Sodium is Na, magnesium is Mg, aluminium is Al, silicon is Si, phosphorus is P, sulfur is S, chlorine is Cl, argon is Ar, potassium is K, and calcium is Ca. These are the first 20 elements in order which you must remember. Now we can get a formula for you to remember these elements. You can write down this formula as I was taught. Hydrogen is high, Helen, listen, B, B, C, news on Friday night. Hi, Helen, listen, B, B, C, news on Friday night, which is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. The other half is some men are sincere people. Smart, caring, and potassium, calcium. This is the other half. You can remember as some men are sincere people, smart, caring, and potassium, calcium. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Sodium represented as Na, magnesium as Mg, aluminium as Al, silicon as Si, phosphorus as P, sulfur as S, chlorine as Cl, argon as Ar, potassium is K, and calcium is Ca. Now these are the first 20 elements and they must be remembered in this order as they will come in the atomic mass in the periodic table. The next subtopic is atomic characteristics. Now what is atomic number? Atomic number is the number of protons in the nucleus of an atom. As we saw, the atom with the nucleus and energy levels. This is an atomic representation of an atom. The nucleus has protons and neutrons. So what is atomic number? Atomic number is the number of protons in the nucleus of an atom, and protons are positively charged. What is mass number? Mass number is the sum of protons and neutrons in the nucleus of an atom. So if this is the nucleus of an atom, P and N, this is mass number. P only is atomic number. Atomic number is number of protons, and mass number is sum of protons and neutrons in the nucleus of an atom. Atoms, as you can read this, atoms are represented by writing the mass number as a superscript and the atomic number as a subscript on the left hand side of a chemical symbol. What do I mean by this? For example, we use sodium, atomic representation of sodium. Sodium is the chemical symbol of sodium is Na. The mass number is written as a superscript on the left hand side, which is over here. This is the mass number. You write the mass number over here, and the atomic number is a subscript on the left hand side of the symbol. So Y will be atomic number. This is the sum of protons and neutrons in a nucleus of an atom. Atomic number is only the protons. What does this help you? This helps you derive the number of neutrons in the nucleus of an atom. So for example, the mass number of sodium is 23. Let's say the mass number of sodium is 23 and the number of protons are 11, because we saw sodium is number 11 in the first 20 elements. So any element, if it has the number of the element in the first 20 elements, derives the number of protons it has. So for example, if oxygen is number 8 in the first 20 elements, it means it has 8 protons and 8 electrons. So sodium is number 11 in the first 20 elements. So it has 11 protons, and the sum and the number of protons and the number of electrons are equal, because protons are positively charged. Protons are positively charged. Electrons are negatively charged. So this is what makes an atom neutral. Neutrons have no charge. So back from that, this is an atomic representation of an element which is sodium. Sodium represented as Na, mass number is 23, written as the superscript on the left hand side, and atomic number written as the subscript on the left hand side. Now this is superscript, this is subscript, this is mass number, 23 is the mass number and 11 is the atomic number. What does this help you divide? If mass number is equals to protons plus neutrons, and the mass number here is 23 and the protons here are 11, how many neutrons are there? 23 minus 11, which is coming to 12. So this helps you derive the number of neutrons in sodium, which is 12. Now an example for you. Calculate the number of neutrons in a chlorine atom, of course in the nucleus, if its atomic number is 17 and mass number is 35. Now if you want to represent this question chemical, what you can do is write chlorine, write the symbol of chlorine, which is Cl, number 17, chlorine, Cl. So you write Cl. What is the atomic number? Atomic number is 17. How is atomic number written? Subscript on the left hand side. So atomic number is 17 and mass number is 35, superscript on the left hand side. Now you have been told determine the number of neutrons, calculate the number of neutrons. What will you do here? Mass number is equals to protons plus neutrons. Mass number is 35, protons is equals to 17 plus neutrons. So 35 minus 17 gives you 18, which are the number of neutrons in the chlorine atom. Another example is the number of neutrons in element A below is 20. Determine the atomic number. A is 39 and X. Determine the atomic number, which is the value of X. Now what is X? X is the number of protons in the nucleus of an atom. You have been told the number of neutrons in element A below is 20. So mass number is 39, X is protons and N is 20 as you have been given. How do you calculate? Mass number is equals to protons plus neutrons. 39 is equals to X plus 20. 39 minus 20, 19. So your answer is 19 is the number of protons in the nucleus of an atom. Protons, which is also represented as atomic number. The next subtopic is relative atomic mass and isotopes. Now what is relative atomic mass? In short, RAM. What is RAM? RAM is the mass of an element compared to 1 over 12. Is the average mass of an atom compared to mass of 1 over 12 of an atom of carbon 12. Carbon 12 is just the isotope carbon with 12 atomic number, with 12 mass number, the number of the sum of protons and neutrons. What is RAM? RAM is the average mass of an atom compared to mass of 1 over 12 of carbon 12. Now we won't dwell on the meaning of RAM because it is not tested, but we will go to The calculation, it is measured using a mass spectrometer which also measures percentage abundance. RAM is measured using an instrument called a mass spectrometer. A mass spectrometer which also measures percentage abundance. What are isotopes? Isotopes is what enables us to calculate RAM. Isotopes are atoms of the same element with the same atomic number but different mass number. Now we know the meaning of atomic number, which are number of protons in the nucleus of an atom. We know the meaning of mass number, the sum of protons and neutrons in the nucleus of an atom. So when I tell you isotopes are atoms of the same element with same atomic number but different mass number, what do I mean? We have seen the first 20 elements. Now for example, we have an example here. Chlorine has two isotopes. They have different mass number. They have same atomic number but different mass number. They have same number of protons but different number of protons and neutrons. So this tells you that the difference in mass number is due to the difference in number of neutrons. So chlorine has two isotopes, chlorine 3517 and chlorine 3717. Now in this chlorine 3517, it has 18 neutrons. In chlorine 3717, it has 20 neutrons. So these are atoms. These are two chlorine atoms of the same element. They are both chlorine, but one has 18 neutrons and the other one has 20 neutrons. The same way, hydrogen has three isotopes. Hydrogen 1 which is called protonium, hydrogen 2 which is called deuterium, and hydrogen 3 which is called tritium. Now as you can see here, hydrogen 1 has one atomic number and one mass number. This tells you that the number of neutrons in hydrogen 1 are 0. Hydrogen 2 has two mass number and atomic number of 1. This tells you that the number of neutrons in hydrogen 2 are 1. Hydrogen 3 has atomic number of 1 and mass number of 3. This tells you that the number of neutrons in hydrogen 3 are 2. So hydrogen 1 doesn't have neutrons, hydrogen 2 has 1 neutron, and hydrogen 3 has 2 neutrons. But they are all hydrogen atoms. So these are what are called isotopes. Atoms of the same element, hydrogen, with same atomic number, but different mass number, 1, 2 and 3. So RAM, relative atomic mass, is calculated about isotopes. The calculation of relative atomic mass. Now as we saw, relative atomic mass is calculated about isotopes, and isotopes have same atomic number but different mass number. So we will go to the calculation. This is the formula of calculation of relative atomic mass as used in KCSE. Now this question had come in our exam and it will come in yours. It is an almost compulsory question, so you have to know how to calculate relative atomic mass. Relative atomic mass is calculated by mass number 1 times relative abundance 1 over 100 into brackets plus, open the bracket, mass number 2 times relative abundance 2 over 100, and you close. Now this is calculated separately, this is calculated separately, and then you add the two. Now what do I mean by mass number 1? Mass number, as we know, is the sum of protons and neutrons. What is mass number 1? Mass number 1 is the mass number of the most abundant isotope. Relative abundance 1 is the percentage abundance of the isotope in the element. Now mass number 2 is the mass number of the less abundant isotope, and so the relative abundance Ra2 will be automatically less than Ra1. Now Mn is mass number, Ra is relative percentage or percentage abundance. The isotope's relative percentage must add up to 100%. Now I will show you an example of calculation of RAM. Calculation of RAM. So calculation of relative atomic mass. Chlorine has two isotopes, chlorine 3717 and chlorine 3517, as we discussed earlier. with percentage abundance of chlorine 3517 is 75%. Calculate the relative atomic mass of chlorine. Now how do you start? You start by writing the formula, which is RAM is equals to mass number 1 times relative abundance 1 over 100 into brackets plus mass number 2 times relative abundance 2 over 100. Now, as you have been told, the percentage abundance of chlorine 3517 is 75%. So chlorine 3517 is 75%. So, and you have been told the relative abundance of isotopes must add up to 100%. So automatically, if chlorine 3517 is 75, what is chlorine 3717? 100 minus 25, which is 25. So chlorine 3717 is equals to 25%. And you can calculate from there by mass number 1 is the mass number of the most abundant isotope. Which one is the most abundant isotope? It is chlorine 3517 with 75%. So the mass number of the first isotope you will use is 35, and you will not use 37 because 35, although it is smaller, it is less abundant. You look at the percentage abundance. So mass number 1 you will use as 35 times relative abundance 1 of the most abundant isotope, which is 75 over 100 plus mass number 2, which is 37. You won't look at the atomic number 17, no, you will look at the mass number. So mass number 2 is 37 times relative abundance 2 is 25 all over 100. Now if you calculate this, you will get 26.25 plus 9.25, which equals to 35.5. 35.5 is the answer to this question as the relative atomic mass of chlorine. Now this brings me to my next point. We will not put any units to the relative atomic mass because it is a ratio. It is a ratio with one compared to another isotopes. And secondly, the confirmation that your answer is right is the relative atomic mass is always closer to the mass number of the most abundant isotope. The relative atomic mass is always closer to the mass number of the most abundant isotope. What do I mean by that? As you can see, the relative atomic mass is 35.5. It is closer to 3517 than 3717. So this gives you a confirmation that your answer is right because the most abundant is chlorine 35, which is 75%, and your answer is closer to 35, being 35.5. Another example. Carbon exists as two isotopes, i.e. carbon 12 and carbon 14. In the ratio 4:1. Calculate the RAM, relative atomic mass of carbon. When you have been told to calculate the relative atomic mass, the first thing you will do is write the whole formula, which is RAM is equals to mass number 1 times relative abundance 1 over 100 into brackets plus mass number 2 times relative abundance 2 over 100. Now, as we discussed, these two, this is calculated separately, this is calculated separately, and then they are added. What is mass number 1? Mass number 1 is the mass number of the most abundant isotope. Now, as you can see the question, two isotopes, carbon 12 and carbon 14, in the ratio 4:1. So you will convert this ratio into a percentage. So the percentage of carbon 12 is 4 over 5 times 100, which is 80%, and the percentage of carbon 14 is 1 over 5 times 100, which is 20%. Now you can now substitute the relative abundances and the mass numbers as respectively. So which one is more abundant, carbon 12 or carbon 14? You have been told exists as 4:1. So automatically carbon 12 is more abundant. So it will take the mass number 1. Carbon 12 mass number 1 times, what is the relative abundance of carbon? Carbon 12, it is 80% over 100 plus, what is mass number 2? Mass number 2 is the mass number of the less abundant isotope, which is carbon 14. So you will put carbon 14 times 20 over 100. You calculate this separately, you get 9.6 plus 2.8, which is 12.4. Now this is the relative atomic mass of carbon 12 and 14 with these relative abundances. Now, how do I confirm my answer is right? 12.4, the relative atomic mass is always closer to the mass number of the most abundant isotope. In this case, the most abundant isotope is carbon 12, and your answer has come to 12.4. So is your answer correct? Yes, it is, because 12.4 is closer to 12 than 14. This is a confirmatory test for your answer of relative atomic mass. Our next subtopic is energy levels and electron arrangement. Now, as we discussed earlier, what is an energy level? An energy level is the area around the nucleus, where electrons are found. So we will just draw an atomic representation here. We have a nucleus, and then we have energy levels surrounding the nucleus. Now this can be an atom of any element. What we will learn in this subtopic is energy levels and how electrons are arranged and electron configuration on the energy levels. Now energy levels are identified by its position from the nucleus. So if this is the nucleus, this is energy level 1, this is energy level 2, this is energy level 3. Now, as we go to electron arrangement, energy levels are areas around the nucleus where electrons are found. So we have to see how many electrons can an energy level maximum hold. So we have a formula for that, which is 2n squared. The formula for electrons, maximum number of electrons in each energy level is 2n squared, where n is the number of energy levels, the position from the nucleus. So for the first energy level, substitute n with 1. So n squared will be 1. 1 times 2 is 2. So the maximum number of electrons the first energy level can hold is 2. First energy level, 2 electrons. Second energy level, substitute n with 2. 2 squared, 4 times 2, 8. So second energy level, 8 electrons. The third energy level, 3 squared is 9, 9 times 2 is 18. So the third energy level, 18 electrons, and so on and so forth. Now, the first energy level can maximum accommodate 2 electrons, second energy level 8 electrons, third energy level 18 electrons, and the fourth energy level 32 electrons. So how do we start the electron representation on the atom? Let's say we have an atom of sulfur. How will sulfur be represented? We have the nucleus. What is the the chemical symbol for sulfur? It is an S. So in the nucleus, you will have an S representing sulfur. And now draw energy levels around this S. So energy level number 1, energy level number 2, and energy level number 3. Energy level 1, energy level 2, energy level 3, and this is the nucleus. Now, how many electrons does sulfur have? How do we know that? We check the number in the chemical, in the first 20 elements. We check the number of sulfur in the first 20 elements. The number of sulfur will give us the number of protons, and the number of protons always equal to the number of electrons. We already discussed that. So, sulfur is number 16. Sulfur is number 16, atomic number 16. So it has 16 protons and 16 electrons. Now how will 16 be represented? As we saw, the first energy level can accommodate a maximum of 2 electrons. The second energy level can accommodate a maximum of 8 electrons. How many are left? 16 minus 2 and 8? 10. 16 minus 10? 6. So the third energy level will have 6. Now how are electrons represented? Electrons are represented with dots or crosses on the energy levels. So if we start representing these electrons on this energy level, we have the first energy level will have 2 electrons. Now mind the position of the energy level. It will have 2 electrons. The second energy level will have how many electrons? 8. So you have 2 on each side of the circle. 2 on the right side, 2 on the upper side, and 2 on the left side. How many are these? These are 2 and 8, 10. How many are left? 6 are left. So you can put any 2 in pairs. So you have 2 here, 2 here, 2 here. So instead of putting these 2 here, you can also put them here. There is no problem. It is all the same. So what can you see from this? You can see that 286 has been represented with the first energy level having only 2 electrons, only 2 in a pair, not 1 here and 1 here, in a pair. The other 8 electrons in the second energy level have been represented as 4 pairs with crosses, and the other 6 have been represented as 6 crosses in pairs. This is the atomic representation of sulfur. We can have the atomic representation of sodium also. Let's have the atomic representation of sodium. Sodium. This is the nucleus. What is the chemical symbol of sodium? Na. So Na. This is the nucleus. Na represents the nucleus of sodium. The first energy level, the second energy level, and the third energy level. What is the number of sodium in the first 20 elements? Sodium is number 11. So what is the atomic number of sodium? 11. That reflects the number of electrons, which are the same as the atomic number, the number of protons, which are also 11. So atomic number of sodium is 11. How will 11 be represented? 11, the first energy level has 2 electrons, the second energy level is 8. Then you see how many are left. 1 is left. So 1. How do you represent 281? You put dots or crosses. You can even put dots. So I will have 2 electrons, 2 dots on my first energy level, another 8 dots on my second energy level, 2, 4, 6, 8. and the third energy level will have only one electron, which you can put on the upper side, on the lower side, on the right or on the left. So I will put it on the lower side. So now this is the atomic representation of electrons in sodium. Not atomic representation, electron arrangement, sorry. Not atomic representation. Electron arrangement of sodium is 2 on the first energy level, 8 on the second energy level, and 1 on the third energy level. So this is first energy level, second energy level, and third energy level. So you can represent the same sodium, the same atom of sodium. You can write the electron arrangement. This was drawing. We have drawn the electron arrangement of sodium. Now instead of drawing, we can write the electron arrangement of sodium. As we saw, sodium is number 11, so it has 11 electrons, written as 2, 8, 1. So this is exactly how the electron arrangement is written, with either dots or crosses between the numbers. Now no dashes are allowed, no Roman numbers, no messing around, nothing. We will just have the numbers of electrons represented and in between dots or commas. So let's say I want to write the electron arrangement of magnesium. Magnesium Mg is number 12. The first energy level has 2, that is we know. The second energy level has a maximum of 8. How many are left? The third energy level has only 2. So this is write the electron arrangement of magnesium. This is what you will do. Or you can use commas. You can write 2, 8, 2. This is also another way of writing. These are the only 2 ways of writing electron arrangement. Anything more messing up this will be given as a direct wrong, and even half a mark is important in chemistry. So you have been told, write the electron arrangement of phosphorus. For example, write the electron arrangement of phosphorus. You will first look at the number of phosphorus in the first 20 elements. Phosphorus is number 15. So you will write phosphorus, which is represented as P, and number 15. Or not here, just write P15. So this shows you the number of electrons phosphorus 15 has, which are 15. So the first energy level has 2 electrons. The second energy level has 8 electrons. And the third energy level has 5 electrons. So this is how phosphorus is represented as 2, 8, 5. This is the electron arrangement of phosphorus. Or instead of dots, you can use commas here. You can use a comma here and a comma here. These are the only 2 ways of writing electron arrangement. If you are told this is right, if you are told to draw, you will draw the atom of phosphorus and represent the electrons. Draw the atom of phosphorus, nucleus. We have the nucleus P, we have the first energy level, the second energy level, and the third energy level. Now phosphorus, you will have P, you will have 2 electrons in the first energy level, 8 electrons in the second energy level, and 5 electrons in the third energy level. This is draw the electron arrangement of phosphorus. Now you can be told to draw an atom with only 2 energy levels, with electrons less than 10. Let's say you are told to draw the electron arrangement of neon. Neon is number 10. So draw electron arrangement of neon. What will you do? You will draw the nucleus and write Ne in between. Ne represents neon. Draw the first energy level and draw the second energy level. Full stop. That covers the end of your energy levels, because neon has number 10. It has only 10 electrons. Only 10. So the first energy level will take 2 and the second energy level will take 8 with crosses or dots. This is how neon has been represented. End of story. If you have been told to write the electron element of neon, you will write 2, 8. Finished. Simple. Or 2, 8. That's how neon will be written. Now, you can also be told to write the electron arrangement of calcium or potassium. Now, potassium has 4 energy levels. This is what I want you to note. We say the first energy level can take a maximum of 2 electrons, the second energy level can take a maximum of 8 electrons, and the third energy level 18 electrons. Now for the first 20 elements, that is not the case. The third energy level can also take a maximum of only 8 electrons. Please note this. The third energy level of the first 20 elements can also take a maximum of only 8 electrons. So if you are told to write the electron representation, write the electron arrangement of potassium. Potassium is number 19. So the first energy level has 2, full stop. The second energy level has 8. Now the third energy level does not have 18, it also has 8. Then you add 2 plus 8 plus 8 is 16, is 18. Potassium is number 19. Potassium represented as K is number 19. So 19 minus 18, 1. So 2881 is the electron arrangement of potassium. For calcium, number 20, the electron arrangement is 2882. Now that marks the end of our first I have covered the half topic, because there is the periodic table which will be covered in the next lesson. I hope you enjoyed the lesson. I hope you have learned atomic structure, atomic representation, electron arrangement, and hope to see you soon. Goodbye, take care, have a good day.